Episode 154 of CppCast, recorded June 11th, 2018. This episode of CppCast is sponsored by Backtrace, the turnkey debugging platform that helps you spend less time debugging and more time building. Get to the root cause quickly with detailed information at your fingertips. Start your free trial at backtrace.io/CppCast. In this episode, Jason and I discuss some Visual Studio and WebAssembly news. Then we talk about the Rapperswil ISO C++ meeting. Welcome to episode 154 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I am all right, Rob. You know, we keep saying the only podcast for C++ developers. Are we just going to leave that in there indefinitely?
I think, we talked to John and Phil, and they said that they're fine with us sticking with it, and they'll call themselves the other only podcast or something like that.
Yeah, right.
Yeah.
We could say the original or the favorite or...
Oh, that's a little mean to call ourselves the favorite. I think that's meaner than saying the only. Yeah, we'll have to think more about changing it to the original. That might work. Yeah.
Well, whatever. Yeah.
Well, at the top of every episode, I'd like to read a piece of feedback. This week, we got a tweet from Todd saying, "Nice episode on VC Package. Interested in doing an episode on SPAC PM." And, we've talked about VC Package a couple times. Obviously, did last week's episode on it, and we've talked about Conan several times. I have not heard of SPAC. Have you, Jason?
I have not heard of SPAC at all, and in fact, I am attempting to look it up right now.
Their website is spac.io.
Okay.
It says it's a flexible package manager that supports multiple versions, configurations, platforms, and compilers.
Python, R, C, C++, or Fortran.
Oh, it's not just C++. Oh, interesting. Okay.
Yeah, that is interesting.
Yeah, we'll have to look into this one a little bit more, and maybe we will try to get them on the show.
Yeah. Could be interesting.
Well, we'd love to hear your thoughts about the show as well. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com, and don't forget to leave us a review on iTunes. So, we were going to have a guest on today who was at the Rapperswil ISO C++ meeting. Unfortunately, he was feeling a little under the weather and couldn't make it. But we wanted to make sure we got in an episode this week. So we have a couple news articles to discuss, but we also have this very thorough trip report on Reddit C++ from Bryce Lellback, and also Nevin Lieber, I think, worked on this, and a third person who I don't recognize. So yeah, we'll go over some news, and we'll talk about this report. I'm sorry we don't have a guest who is there to talk about it with us, but yeah, should be an interesting conversation, I hope.
And we'll see what happens. It might be a little bit short episode, so we'll just have to fill it with random things like I am right now.
Okay. Well, the first thing I have is a post on the Visual Studio blog, and there's not too much meat in this article, but it's basically saying the next Visual Studio version will be Visual Studio 2019, which makes sense. I think we would have heard about it by now if they were going to do a 2018 release. So yeah, the next big version will probably be like summer or fall next year. They're not putting down an actual date yet. They're not really saying a whole lot about the release in general. Although the one thing that I found to be really interesting was they linked to this other website where you can see the Visual Studio roadmap. And currently the roadmap is just referencing, 2018 Q2 and Q3, which will still be the 2017 release, obviously. But I wasn't aware that they gave us this much information ahead of time before. And just to highlight some of the things that are in this roadmap for the rest of this year, 2018 Q3, for C++, they have one feature labeled See Just My Code in the debugger in C++ and use step back in the debugger for C++. So the step back part, I'm not sure if that's like full reverse debugging or if it's just, I don't know, kind of a lighter version of that, but it sounds cool.
Yeah, I'm not sure about either one of those, but I think I saw something, I think I saw some preview of this step backward in the debugger, reverse debugging stuff for C++ in a recently release, but I could be misremembering something also.
Well, that one says Q3, so I don't think it would be out yet unless you were looking at a preview.
Yeah. I might have been looking at a preview of the next release of Visual Studio. It's interesting, this upcoming Visual Studio 2019, in a way, I don't know how to say this without sounding like I'm trying to be rude or anything, but in a way I don't care, but I will clarify, and that is because they have been making such good updates to 2017.
Yeah.
Every quarter we're getting significant updates to the C++ stuff. In my mind, that could have just continued indefinitely. Why do we need a whole new Visual Studio release? But, they have their plans.
Yeah.
I also wanted to point out that they say on here that you might start noticing all of the commits that we're doing to GitHub leading up to this release, basically.
Yeah, so in addition to just looking at that roadmap, you can actually just stalk them on GitHub and see what they're up to, which is kind of cool.
Yeah.
So the next thing I have, and this was a month ago actually, but it just was reposted on the C++ subreddit and I saw it. And this is from Google I.O., which had their conference last year. And I've never been to I.O., but I'd imagine most of the content at I.O. is kind of focused on Android and focused on web development and JavaScript and stuff like that. But they did a session called Build the Future of the Web with WebAssembly. And I thought it was a really great session. We talked about WebAssembly a while back with JF Bastian. And Google is highlighting, kind of the current state of WebAssembly, and they showed some demos of actual companies making products on the web using WebAssembly, which I thought was really cool. And these are real deal applications AutoCAD, which has been a really powerful desktop application for years, has ported the app onto WebAssembly. And they had a really interesting story because they talked about how they had kind of tried doing a web version of AutoCAD a couple times. And they first tried it with Flash and that didn't really go too far. and then they tried making a, full port in pure JavaScript. And they kind of got a basic viewer and realized, hey, we're going to have to rewrite a ton of code from C++ to JavaScript if we want to do this, and it's going to take forever and be really unperformant. So now they have WebAssembly, and it's a really great story, and the application looks fantastic.
Yeah, I've heard that WebAssembly is just maybe 20. No, what's the word I'm looking for? It's 75% the speed of native or something like that. It's pretty darn close to native or better than that. I mean,
for a web application, that's huge compared to JavaScript performance, I'd imagine.
Yeah. Oh, well, yeah. Although the JavaScript interpreters these days are just insane. But yeah. I mean, we've had other guests on that have talked about this, how WebAssembly or ASM.js and taking advantage of the optimizing compiler that C++ has and just being able to execute much more dense code is itself much faster than native JavaScript in many cases.
Yeah. And I thought it was really interesting how the other application they showed was able to mix WebAssembly with JavaScript. I think they said some parts of their UI was React.js. I'm not too familiar with that, but I I guess I hear a lot on Twitter. But it was React.js UI, and then you had like, I think it was a design tool, and then you had a work surface, which was all in WebAssembly. And that wasn't even like a port of an application. That was a completely new application that they, or maybe it was a port of a Mac application. But anyway, it was another really impressive piece of work with WebAssembly.
It's an interesting world we're entering into here.
Yeah. And if you're interested in learning a little more, obviously I recommend watching the talk, but they also put out this link to where you can see a kind of quick demo of WebAssembly in action with this hourglass thing that's, I guess, using actual physics to calculate the, granules of sand going down the hourglass. It was kind of cool.
Huh. Yeah, that is pretty neat.
Yeah. Okay. Next one. And this was posted a couple of days ago. I'm not sure if this was, I guess it was presented at Rapperswil, but this is a paper called Core Coroutines. I didn't really see this referenced in the main trip report paper we're going to discuss. Have you?
No, I don't think so.
Yeah. But anyway, this paper is titled Core Coroutines, Making Coroutines Simpler, Faster, and More General. And, I'm not sure how I feel about this one. I mean, coroutines, they're supposed to make it into C++ 20. And I guess this paper is trying to change the syntax and change a couple things about how coroutines would work. I'll be honest, I don't like their alternative syntax.
You don't like the arrow operators everywhere kind of thing?
Yeah, so they're saying instead of co-await, it would replace it with square brackets with an arrow in it. And I don't know, I wish it was just await, but I like co-await more than these brackets, I think.
Well, yeah, and await, they risk that being too conflicting with existing code. Co-await will probably conflict with some existing code. Spelling it this, as they put it, spelling it this way with this operator, it probably has very little overlap with existing things. And it's weird to see this operator overload and partially down halfway through the paper. So that's like operator, open square bracket, less than, minus, close square bracket. You're like, yeah. But I don't know. I haven't spent any time with coroutines yet to feel like I have an opinion strongly on this. But I know we've heard Bjarne say in the past that like anytime a new feature gets added to the language, people want the syntax to be really verbose because it's a new thing. And then after a couple of years of using it, everyone's looking for a way to have the syntax more terse. So it's an interesting, at least the idea of can we jump out of the gate with this more terse syntax? And I mean, we see this happening with concepts. Yeah. Over and over again too.
Yeah. I don't know. I just feel like I'm fine with co-await. I haven't used it much, so I wouldn't say I have a strong opinion, but I don't know. I just like a simple keyword more than these extra characters. I don't know.
Well, okay, let's clarify. You say you haven't used it much. Have you used coroutines?
No. I mean,
okay.
I'm familiar with the await syntax from other languages, and maybe that's why I also like co-await, because it's more familiar to me from seeing it in other languages.
Right.
Which is maybe a reason to stick with that, so that someone coming from another language like C# into C++ would kind of recognize the keyword that kind of functions the same way.
Yeah, but this does have an interesting kind of syntax. It's like, oh, well, this thing yields a value to this thing, which yields a value to this thing. I mean, it kind of looks like a thing.
Yeah. Okay, next one, and this is not really C++ related, but it's kind of interesting in general to most programmers, I think. I saw a lot of people talking about it on the internet last week. Microsoft bought GitHub.
Yes.
Yeah. And the article I have here is actually the Linux Foundation's response to that news. And I know there seem to be some people who are kind of freaking out over Microsoft buying GitHub. I saw there was some news about, GitLab and an alternative, getting a lot of traffic of people moving their repositories. Mm-hmm. And I actually use GitLab too, and it's a perfectly good tool. But I think the people who are freaking out and wanting to move from GitHub to GitLab are jumping the gun a little bit. I don't really think that's necessary. And it seems that the Linux Foundation is basically saying that they agree, that they think this is a good move, and they're not really worried about Microsoft doing anything bad with people's source code or anything like that.
And I feel like a little bit of competition is never bad. No. So in a way, this is for the people who are jumping ship to GitLab or to other services, at least it's giving a shot in the arm to the other services, which will help them compete a little bit more and keep everyone on their toes.
Yeah.
But
I think Microsoft has good intentions. I mean, they've done so much open source work over the past few years. If this happened like 10 years ago, people might be more valid in their concern. But Microsoft has, I think, earned a lot of goodwill from the open source community lately.
Yeah, a lot of their projects are like TypeScript, almost completely open source, I believe. And yeah.
Okay, so we want to talk more about the Rapperswil ISO C++ meeting. As we said, obviously we weren't there, but we have a nice trip report to look at. And it looks like the biggest new item that happened last week was contracts made it into the C++20 draft.
Yeah, that's fascinating to me because I thought from the last hypothetical roadmap that we saw that we didn't expect contracts to necessarily end up until 23, or at least, right? Okay. I thought it said that 20 was an optimistic goal and 23 was the realistic goal. Maybe I'm remembering that backward, but either way, it's in.
Yeah.
And actually interesting, the paper that was linked to hasn't been updated since 2016.
Yeah, that is interesting. I wonder what changed to get it in if the paper is the same.
Maybe it was just enough community consensus that it was necessary.
Yeah.
So have you spent any time looking at contracts?
I did spend some time looking at the paper, and I'm not sure if it's something I'm going to use, but it certainly looks like it would be very helpful for library developers.
I became convinced my schedule's been busy. The last training that I did, the students there very concerned about code quality and security of code.
Okay.
And it seems they would be very interested in this. And as I started thinking about it and talking about it with them, I became convinced that this is probably the main thing that's going to affect real C++, real C++ developers, the, nominative C++ developer around the world. Because you can specify okay, this function expects a value that's less than 2, and at the end of it, it guarantees, expects, what's the other keyword? Ensures that whatever the state is of something will still be true at the end. And these, it's going to be up to the compilers, I think, to what the various different ways are that they can be compiled and enforcement for them. Here we go. 3 levels of contracts: default, audit, and axiom. But it may or may not add runtime overhead. And I don't know. I think it's a good add-in to the language, personally. I'm glad to see that we've got it in.
What is that default, axiom, and audit? Okay, so that's whether there's runtime checking or audit means this check is expensive. Do you know more about that?
I do not.
Okay.
But can control what is checked and what is done in response to a violation. Yeah, so if I remember correctly here.
Oh, it's saying, okay, so yeah, go ahead.
Go ahead.
Saying default, the cost of runtime checking is assumed to be small or at least not expensive. Audit, a check that is more comprehensive than default. The cost of runtime checking is assumed to be large compared to executing the function. An axiom is a formal comment for humans and static analyzers. There's no runtime cost because the predicate is not evaluated at runtime.
And then when you compile, you have 3 different options. You can say that your contracts are off, so it adds no runtime overhead at all. default says the contracts are checked, and audit says default and audit contracts are checked.
Okay, so maybe something you might want to do is have like a debug version where you're going to have all your checks in place and hope that your QA team would run into anything.
Right. Yeah. So default would build an audit mode saying all checks are all checks are executed regardless of the cost. Right. And then your release build might be built in default mode that says only the non-expensive ones are checked at runtime.
Okay.
Or if you had you're saying, no, I need super performance, but I need to make sure that my CI does the right thing, then your continuous integration build in default mode and then in your release build with them disabled or something like that. But either way, it's more code documentation and hypothetically information that the compiler can optimize around.
Okay, right.
I mean, hypothetically, I don't believe that's any kind of a guarantee in here, but if you say, in my contract, this value is never going to be greater than 4 or less than 0, then perhaps the compiler could omit different code in those cases.
Right.
Hypothetically.
And correct me if I'm wrong, but it looks like if any of these conditions are not met, you just get an immediate program termination.
It should be the same as an assert, I believe.
Okay.
Let's see. You can also have a violation handler, it looks like. I definitely need to spend more time looking at this. But, more ways to document our code and more ways to put guarantees about what our code is doing.
Yeah.
I'm cool with that.
Definitely a good thing. Okay. Next. The next item is standard library concepts. So I guess we already have concepts going in for C++20, so this paper is to make sure the standard library is implemented with them?
Yeah, that sounds right, because I know concepts had to be done in multiple stages. They had to get approved first, and then the standard library had to be applied to them, and then they're going to talk about more terse syntax and those kinds of things.
Right, and we're still waiting to see if any of the terse or syntaxes go in or not, I believe.
Yeah, at this point, I think I'll be surprised if that makes it into C++20, but who knows?
Okay. Did you read about this one much, the class non-type template parameters?
That is at the top of my to-do list to make sure I fully understand what's going on in here. But I mean, currently a template parameter can be any primitive thing. It can be a bool, an int, or a size t, or whatever, or a type. And I believe the main point of this is just to extend it so that instead of just primitive things, it can be anything that meets certain requirements here. Must be equality, comparable, which relies on our spaceship operator. Mm-hmm. Must have basically a spaceship operator. Let's see. All of their bases and non-static data members recursively have a non-user provided operator spaceship returning a type that is implicitly convertible and contain no references. Yeah.
Okay. I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. Backtrace is a debugging platform that improves software quality, reliability, and support by bringing deep introspection and automation throughout the software error lifecycle. Spend less time debugging and reduce your mean time to resolution by using the first and only platform to combine symbolic debugging, error aggregation, and state analysis. At the time of error, Backtrace jumps into action, capturing detailed dumps of application and environmental state. Backtrace then performs automated analysis on process memory and executable code to classify errors and highlight important signals such as heap corruption, malware, and much more. This data is aggregated and archived in a centralized object store, providing your team a single system to investigate errors across your environments. Join industry leaders like Fastly, Message Systems, and AppNexus that use Backtrace to modernize their debugging infrastructure. It's free to try, minutes to set up, fully featured with no commitment necessary. Check them out at backtrace.io/CppCast. Okay, and then the next one that they're adding to C++20 is going to be feature test macros. And yeah.
I want that.
Yeah, so this is just going to be, you can add some macro to say, I have sfna or something like that. So if you want to block off some code to use sfna or use some other older piece of code, then you can do that And this is another one which seems like it'd be great for library developers who've been waiting to move their users to a new version. Now you could just use macros and start moving your code forward, right?
Yeah, and GCC and Clang have supported this pre-standardization of it for a while. So in ChaiScript, like I wrote some code that was like, well, if deduction guides are supported, then do this, otherwise do this old thing, basically.
Right.
And actually, that's not quite right, but whatever. Close enough. For the sake of this discussion, it's close enough. And I go to test the code, and it's not compiling on Visual Studio. And I cannot figure out why not. And then I have to go and research, and Visual Studio was not going to officially support it until it was in the standard. Okay. So in Visual Studio, I had to do something that's like, if Visual Studio and the compiler version is greater than this, then do this, otherwise test the feature macro. So, yes, I am happy to see the feature testing macros be official now. It does come up in the real code.
Yeah, it's one of those ones that I'm surprised wasn't in there earlier.
I don't know what the holdup was, honestly, on it, but I'm glad to see that it made it through.
Yeah. Okay. Conditional explicit. I'm not sure if I understand this one. Do you understand this one, Jason?
I do.
Okay.
I think. Understand it. Yes. All right. I'm going to double check. Yeah, that's what I thought. Okay. So right now, a function can be conditionally no except.
Okay.
You can say no except at the end of the function declaration and put in parens some compile time constant expression that would determine whether or not that function should be no except. With conditional explicit up at the front of like your conversion operator or your single parameter constructor or whatever, you can say explicit, as most things should be explicit that would otherwise add an implicit conversion, and have in there some Boolean condition that checks at compile time whether or not that explicit is true there. Honestly, I don't know why it's necessary, because I don't know why, like I don't fully understand why some things are conditionally explicit in the standard currently. And you can find them in pair, tuple, and variant, and optional specifically. All of those types have conditionally explicit constructors. But I don't see the reason for it. I don't see the reason for conditionally explicit. I'm just like, make everything explicit. Like explicit should be our default. Right. I'm tired of implicit conversions. Okay. And it's another syntax thing for me to have to teach.
Yeah. Okay. So we have a couple other things that are added. These ones, seems like there might not be as much to talk about.
Oh, come on. The next one's awesome.
Okay. Virtual calls and constant expressions.
Yes. Virtual calls and constant expressions. Virtual functions can be constexpr now.
Oh yeah, that is awesome.
This is fascinating. I've thought for a long time that final methods should be constexpr, because it's impossible for the thing to go past that point. So why not at least allow the final to be constexpr? But now we can do things with like hypothetically runtime dispatch that happens at compile time and a constexpr context based on what the type of the object pointer was that was passed to the thing. I'm all in favor of more constexpr things.
Yes, this is leading you closer to constexpr all things.
Oh, it is very close at this point, yeah.
Yeah. Okay.
Yes, the next ones now, I'm not sure where we're going with the rest of it.
Yeah, so atomic ref, I didn't read too much into that one. Shift left and shift right algorithms. I think I briefly looked at that one, and it's kind of doing the same thing as move and move backward in simpler syntax.
Yeah, okay. Yeah.
Yeah. They're removing some facilities that were deprecated in C++ 17. What are these? ISPOW2, SEAL2, Floor2?
I believe those are binary versions of these things.
Oh, okay.
Yeah, integral powers of 2. It's all things that are powers of 2. And I read a comment on those here in this Reddit discussion about like, oh, I'm so glad to see POW2, SEAL2, and Floor2, because anyone who does X has to re-implement these every time. And I'm like, I've never seen these functions before. I have no idea what their utility is, but I'll take your word for it. Yeah. There is one bitcast.
Okay.
So reinterpret cast, not 100% of the time, but nearly 100% of the time, is used incorrectly in a way that invokes undefined behavior, technically.
Okay.
Bitcast is a defined way of doing these things. I have a blob of data. I want to cast it to some other type. Let the compiler do the most efficient thing that it knows that it can do in a not UB way. That's awesome. Because currently, to get around this, we have to do things like memcopy from a data stream into a struct, which is almost certainly going to be optimized away by the compiler. But in this way, yeah, this should be good.
Okay.
And JF is the author of it.
Yeah, I feel like I remember talking about Bitcast earlier with, maybe not with JF, but talking about one of his articles earlier. That sounds really familiar to me now. Yeah. Okay, so now he's kind of in this trip report going over individual progress made in the different working groups. So one of the things I wanted to highlight was the executors.
Okay.
I think, we're talking about the optimistic versus conservative estimate. I think it was definitely being put into C++ 23 as the conservative estimate last trip report. But they're now saying it is at least going to make it into a TS in C++ 20 and could quite potentially make it into C++ 20, the standard, the IS, because they're going to have an additional meeting to try and kind of hash out the remaining issues with executors, right?
That's what it seems. I mean, and that's a big deal because we need executors to get networking. Right. There's, I think, a whole bunch of other features that are kind of dependent on getting executors in. Yeah, executors and the updates to the, networking and the updates to futures for sure. Right. And a better future or something. Yeah. People did a lot of puns around the updates to futures, and I'm terrible at them. So yeah, I hope this additional meeting they're going to have goes well, because if we get executors into C++ 20, then that kind of will hopefully push up the schedule for everything else, like networking. Yeah. Now, the sad note for a lot of people paying attention to this is contracts. Okay. Excuse me, not contracts. Concepts. Okay. You know what? Yeah, I need to take 2 steps back. Okay. I mean to say modules both of those times. Modules is the thing that everyone wants, but is like nervously optimistic about, right? We already talked about concepts. Concepts are in. We already talked about contracts. Contracts are in. I don't know why I said those things. Ranges are in. It looks like, and they're because they rely on concepts. So that's good. Modules. Right now, it's saying to expect TSV2 in C++ 20, not yet necessarily being accepted into C++ 20. Well, that's the conservative estimate, the TSV2. They're optimistics still set for C++ 20. And we said there's going to be an executors meeting. I'm not sure if it's the same meeting, but they're also going to have a special meeting just on modules. Okay. Yeah. So 2018 fall EWG modules meeting and 2018 fall LEWG SG1 executors meeting. So, the committee members who are willing to go to an extra meeting to try to hash out these features and get them right for C++ 20 deserve a lot of credit. I'm glad they're doing it. Yeah, that's pretty interesting. That's, cramming in 2 more meetings. Maybe they'll let people call in. I don't think the average listener appreciates just how much traveling the average committee member does. Yeah. I mean, assume like a week and a half to 2 weeks for each committee meeting because you have to deal with jet lag and whatever. And they're a full week long. And there's 4 of them every year. So you're traveling for at least 6 weeks out of the year just for committee meetings. And if you're on the committee, you're probably traveling and going to conferences and other things as well.
Yeah.
I mean, just as take someone like Chandler, 4 committee meetings, plus all of the Clang and LLVM meetings, plus the conferences.
CppCon and other C++ conferences, sure.
Yeah, it's a really, truly a lot of traveling.
And they do all that traveling and then they just sit in meeting rooms all day.
Yeah, pretty much.
Yeah. So yeah, that's modules and executors. What else do we want to talk about? The tooling study group had another meeting. This is their second meeting ever, and says they had representatives from most of the major C++ package managers. Obviously, we talked to Robert from VC Package last week. He was there, but I believe someone from Conan must have been there as well. And they put out 2 papers, C++ dependency management, package consumption versus development. And I read that paper a little bit, and it sounds like they're basically recognizing that other languages kind of have learned a lot with their package managers and are kind of starting to do smarter, more innovative things. And if C++ is going to have a good package management story, we should try to learn from what these other languages are doing and get it right if we're going to be standardizing something.
That sounds reasonable.
Yeah. And there's another paper on modules, macros, and build systems. So I'm glad that they're starting to discuss how modules might work with package managers.
Mm-hmm.
I guess we should talk about the 2D graphics proposal, since we talked about that a bit last time, or last trip report. So they, as we talked about last time, it seems like the 2D graphics proposal got hung up. It had been going along for years, chugging along, and suddenly got met with some opposition. With this committee meeting, there was an actual alternative graphics proposal paper written, and the alternative proposal is basically kind of, for the most part, saying we should just stop working on this. Right?
Yeah, that's what it seemed.
Yeah. So it sounds like they did a vote on whether they should go with this alternative proposal or continue work on the graphics proposal. And that vote, it sounds like it was kind of split.
Yeah.
And go ahead.
Go ahead. No, yeah.
So, I mean, with the vote being split, it sounds like as of now, we're still going to be in limbo with this graphics proposal. Some people might continue working on it, but it's not advancing towards the technical specification and definitely not towards the international standard.
Yeah, it seems to have just kind of petered out.
Yeah, and I feel really bad for all the people who've spent so much time working on the graphics proposal. As we were just saying, it takes a lot of effort just to go to these committee meetings, but it's even more effort to be writing these papers and working on these libraries. So I really feel bad about all the time that several people have spent on this, but I can't disagree with everything that was being said in that alternative paper. Did you read through that one?
I did not, no.
Yeah, so it kind of highlighted the reasons why this particular graphics proposal didn't really make sense. It kind of didn't meet some of the original requirements that were stated for having graphics in the C++ standard. And on top of that, it kind of highlighted that, maybe this issue is really about package management. If we had better package management, then we wouldn't care to have a built-in graphics library. And yeah, I think everything they said was absolutely true. They did outline an actual alternative proposal to create this small library to place things on the screen, because apparently the actual graphics proposal, you need to work with I guess drawing lines and triangles. What they were saying is it should be better if it would be better if it could load up assets and draw those, that might be more useful to game developers and such.
Yeah.
Yeah.
I don't know if you noticed, but Guy Davidson did also publish his own trip report with his direct experience about this.
Yeah. I read through some of that. What was your take on that?
Well, it seemed very disappointing to him, which is understandable. He put a lot of work into it. But then he did have this little note here. He says several thousand hours of work had gone into the proposal. We need a way of preventing this from happening again. Sentiment transformed from strong long-term support in Toronto to ambivalence in Jacksonville, and then basically an end here in Rapperswil.
Yeah, and I'm curious how it got so far without meeting this kind of pushback earlier. I mean, has the concept of package management just become more discussed lately, and that made everyone think, hey, maybe that's a real problem. Maybe we shouldn't be shoving all this into the standard.
I don't know, honestly.
That doesn't seem like it should be that much of a new thought. I don't know.
Yeah. I don't know. It could just be opponents who were choosing to speak up now who didn't before or something. I honestly don't know. And having not been to any of the meetings, I don't really know how these things really go down. And I'm sure we can read all of this trip reports that have ever been written and still not really know what it feels like to be there during the conversation of these things.
Yeah. I'm kind of curious as to whether, did this particular paper, was it brought up in some context every single meeting, or did they kind of go off for a year or two and work on their own without going back to the committee for feedback?
Yeah, and I have no idea.
Okay. Is there anything else that I missed, Jason, that we wanted to talk about?
Just one quick comment that Bryce's trip report says, plus a variety of fixes too long to list here. I really want to know what that variety of fixes is. I tried to find more information and could not. I don't know if I'm going to have to go look at individual papers, but there was a bunch of tiny more updates to ConstExpr in the context of standard algorithms. Specifically, standard swap is not ConstExpr, and therefore none of the algorithms that rely on it, such as standard sort, can be ConstExpr. So one of the fixes that I was expecting to see come through in this was making swap ConstExpr and therefore the cascade of the rest of the standard algorithms that don't require any dynamic allocations being ConstExpr. That's something I'd really like to see. I currently have some hacks in my code that do compile time ConstExpr sorting without using the standard sort. And I would like to, be able to get away from that kind of thing and see that in C++20, but I don't see any updates on that particular paper.
Okay. One more study group trip report that I thought was interesting was the Undefined Behavior Study Group, who said they adopted a policy that not all undefined behavior has to be preserved from one version of C++ to the other. And I thought that was really interesting. You would have thought that they would have already had a goal of reducing undefined behavior, but now they're, I guess, explicitly saying, yeah, we don't feel any need to preserve UB.
Yeah, and there's people that argue that we don't want to get rid of all the undefined behavior because a lot of this is where the compiler is able to operate and do things that we like it doing in the realm of undefined behavior. I don't feel like I'm well informed enough to have a strong opinion in either direction on that. But I do know that technically undefined behavior is not allowed in a ConstExpr context. So the more work that you do at compile time, hypothetically, the less undefined yeah. Although that exact definition, others are quick to point out, is highly dependent on the compiler. Like what things it is going to actually, fail to compile because they're potentially undefined behavior. And I just tested this myself, signed integer overflow does not exist in C++. That is undefined behavior. So I wrote some ConstExpr code that does signed integer overflow just to see if it would compile. And it totally does compile on every compiler that I tried in a ConstExpr context. So it clearly doesn't check everything. But it's at least another thing to look at.
Okay. Well, I think that's everything I wanted to cover from this. You're good?
Yep, I'm good.
Okay. Well, we should be back next week with another guest. Thank you, everyone, for listening, and see you next week.
Later.
Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in. Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. Website at CppCast.com. Theme music for this episode is provided by podcastthemes.com.